Now in this numerical, what they have said, what they have given a balanced star connected. Star connected means this one is the star connected, right? Load they have mentioned, load is how much? That is 8 plus J6 ohm per phase. Per phase means for one single phase load is this one. Okay, load means what is given? They have given Z. Z is how much? 8 plus J6 ohm. Okay, and Z is always in phase. And they had said they are connected to a three phase 415 volt supply. If they don't mention the voltage, that which voltage it is, then we'll always consider it as a line voltage. So line voltage they have mentioned how much? 415 volt, and we need to calculate line current. Okay, now I'm drawing a diagram based on this. Suppose they have set star connection. Star connection is like this, like, right? This is the supply, and this supply of star connection is connected to the load of star connection, like this. This is the load. Here we are having three phase star connection and three phase load connection. This is supply and this is for the load. For supply voltage, how much they have given? VL is equal to 415 volt, and for load impedance, how much they have given? That is Z is equal to 8 plus J6. Clear this thing? Now they are asking the line current. Line current means IR, IY and IB. We need to calculate. This is suppose R, this is suppose Y, this is suppose B. R is connected to R connection, Y is connected to Y connection, and B is connected to B connection. Okay. So for that we should know the formula first. We are having formula that IPH is equal to VPH divided by ZPH, because Z, if it is in phase, then voltage should also be in phase and current should also be in phase. Okay, clear this thing? Now we are having one relationship that VL is equal to root 3 VPH, angle is how much? 30 degree. But what they have given, VL or VPH in the question? Tell me what they have given, VL or VPH in the question. They said voltage is 415 volt, and I told you they didn't mention that whether it is a line voltage or phase voltage. If they never mention, then we'll always consider it as a line voltage. Okay, so we can consider that line voltage is given. How much is given? That is 415 volt. Okay, now we need to convert it into phase voltage. So what is the formula for the phase voltage? That is VPH is equal to VL by root 3, and angle would be minus 30 degree. I told you na, VL is equal to this one, so VPH would be VL by root 3, angle would be minus 30 degree. Okay, this thing clear? Now calculate it. Calculate the phase voltage in this. Now we need to calculate the phase voltage now, because for the formula what we want? Phase voltage. So according to this, VPH is how much? VL is how much given? VL is how much given? We are doing the question practice problem 1. In the question they have given line voltage is 415 divided by root 3. So how much voltage we are getting? 415 divided by root 3 is how much? That is how much we got? 239.6. Okay, now it's fine. Now we need phase voltage. One phase voltage is VRN, one phase voltage is VYN, and one phase voltage is VBN, right? So VRN is how much? VRN how much we got? That is 239.6. VRN is how much? 239.6. And for VRN angle is how much? 0 degree. VYN also magnitude is same, 239.6. But angle is how much? Minus 120 degree. VBN is how much? Again magnitude is same, 239.6. But angle is how much? Minus 240 degree. Remember I told you na VRN will take as a reference always. So first angle is 0 degree because it is reference. Next angle is minus 120 degree and next angle is minus 240 degree. If you don't know, you can draw the angle like the phasor diagram like this. This one is R, this one is Y, this one is B. Right? So angle between R and Y is 120 degree and angle between R and B would be minus 240 degree. Clear this thing? Okay, tell me if you have any doubt. This question you have sent me the Word file. I have just calculated phase voltage. Got it? Yeah. Sh- VPH. From VL, I find VPH. Why I find VPH? Because we are having this formula. Okay, remove that. Don't get confused. Now, I just consider there is a formula that VL is equal to root 3 VPH. Do we know the value of VL? They have given in the question 415 volt. From that, we have calculated VPH. Angle for VRN in the formula I told you. Just see the formula what you have written from the previous. That will be 0 degree. VYN angle between R and Y is minus 120 degree. That's why I wrote it minus 120 degree. If they don't mention any sequence, then we'll always consider it as a positive sequence. This one is RBN. So angle between R and B is how much? Minus 240 degree. That's why I took minus 240 degree. Okay. So all these are which voltage? All these are phase voltage. But magnitude is same, but the angle is different. Okay. Now next we need to calculate current. That is IPH is equal to VPH divided by ZPH. So for first we'll write down for IR. If I'm writing IR for the phase current, then VPH is how much? VRN divided by Z. Z is the, yeah, but in case of star connection, I told you line current is equal to the phase current. That's why I have written this formula. Okay. So VRN divided by ZPH. ZPH is how much? 8 plus J 6. Okay. No, ZL is not any term. ZL, like there is not as such any term. We'll always consider it as ZPH only. VRN we calculated above, that is 239.6. Angle is how much? 0 degree. 239.6 angle is 0 degree. Now this is in rectangular form. For division, we need to convert it into polar form. Okay, convert this 8 plus J6 into a polar form. You know na how to convert? Press shift, then press pole because you need to convert it into polar form. Then pole, comma 8, comma 6. Then you will get a magnitude. What is the value of magnitude you got? I think you'll get 10 around something. And angle would be 36.86. This is only the value you got. Okay, so if we'll solve it, magnitude is divided by the magnitude, then we'll get 23.9, and the multiplication division angle would be subtracted, minus 36.86 ampere. Similarly, we'll calculate for Iy. Iy is what? Vyn divided by, I'm writing down direct this form, 10 angle 36.86. Vy1 is how much? 229.6, angle is minus 120 degree. Only there is a difference in angle. Magnitude is same in each case, minus 120 degree. Then again this one term 36.86. After solving we'll get 23.9, angle would be minus 156.86. Okay. Similarly we calculated for IN, that is, sorry, IB. One is IR, YB, IY and IB, that is VBN divided by the same 10 angle 36.86. After solving we'll get 23.96, angle would be 83.13. Okay, clear? Yeah, it was minus 240. I took it minus 240. Clear? Now we get the line current, and line current is equal to the phase current. They are asking about the phase current or line current. The answer would be same. Next they are asking the power factor. Power factor is, you know, that cos phi, right? Cos phi is how much? That is R divided by Z. Z they have given, that is 8 plus J6. So Z is in the form of R plus JXL. If we'll compare, then R value would be R 8 and Z would be value would be root of 8 square plus 6 square, right? Because that formula is root of R square plus XL square, that is that you have done in the AC circuit, correct? You can calculate it directly also, that Z value you got it, that is 10 angle 36 point, what you got, 36.86. Okay, so Z is 10. So this is 8 divided by 10 is how much you got, that is 0.8. So power factor value you got it as a point. Okay, we don't need the angle because we need to consider only the magnitude. Next in this they are asking about the active power. Active power formula is no, they'll ask the active power, reactive power and apparent power. So for active power we are having formula root 3 VL IL cos phi. If I want it in terms of phase, then it would be 3 VPH IPH cos phi. Okay, there is a formula. We know the value of 3, we know the value of VPH, and we know the value of IPH, we know the value of cos phi. In the power, we never consider the angle. We'll always consider the magnitude. Like 3 we know, right? VPH also we know, that is 239.6. IPH also we know, that is 23.96. Cos phi we just calculated, that is zero point 0.8. So after solving this, we'll get 13.77 kilowatt. That is the active power. Okay. Next they are asking for the reactive power, that is 3 VPH IPH sin phi. This is the formula for the reactive power, or we can consider this one also in terms of line, that is root 3 VL IL sin phi. Okay. 3 we know, VPH we know, IPH we know, sin phi also we know. We can calculate it. After solving it, we'll get 10.331 kVAR, 331 kilovolt ampere reactive. That is the unit of reactive power, right? Next, they want us to calculate apparent power, and apparent power is 3 VPH IPH. Simply we can solve it and we'll get 17.22 kVA.